Motion graphs or graphs in kinematics. In this category, we are going to discuss the first part, that is distance time graph. We will not only study about the distance time graph, we will compare this with the displacement time graph also. So here the axes are shown and a stationary car is also shown here on the right side and the timer. What is to be taken along y-axis? Distance. And what is taken along x-axis? Time. And this is usually the practice. Time is taken in along x-axis in velocity time graph, distance time graph, acceleration time graph, etc. So in the beginning, the car is at rest and we assume that it moves with the constant speed. In 30 seconds of the journey, car has suppose traveled 30 meter and it stopped and remained at rest for about 15 seconds. So this part of the graph, which is just sketched or plotted, that shows the constant speed and then the no motion of the car. The car turns back and goes to the starting point with faster speed. Here, because this is distance time graph, the change in direction is not to be considered. And distance is never negative. It never decreases. It is not negative. So the graph will be rising simply. So the straight line passing through the origin, it is the slope that shows the uniform speed because it is a straight line. Then the next part, it is parallel to the time axis and it indicates no motion. That is, the car was stationary for about 15 seconds. And then car returned and it moved back with the faster speed to the starting point and stopped. So the total distance covered by car is 60 meter in 60 seconds. So if we calculate the average speed using the formula S is equal to Vt, the answer will be 1 second. But here the speed is not same throughout the journey. In different parts, the speed is different. S is equal to Vt or V equals to S upon T. The gradient of speed time graph, distance time graph gives us speed. So what is the speed in the first part? Distance covered is 30 meter and time is also 30 seconds. So the speed in the first part is 1 meter per second. Now in the second part, after the car moved back, what is the speed of the car? We have to calculate the gradient of the next part. The maximum distance which was traveled is 60 meter and starting point after returning is 30. So 60 minus 30 is the change in distance over change in time. 60 minus 45. Speed is 2 meter per second. The first part had speed of 1 meter per second. This slope is steeper. This graph is steeper, means the gradient of this portion of the graph is greater. But both have one thing common, that is the constant speed. If we consider the change in direction of motion of the car when it returned back to its starting point, what is to be done? Instead of plotting distance time graph, we will have to replace it with displacement time graph. And displacement time graph, because displacement is a vector quantity, whereas distance is a scalar quantity. So change in direction is to be considered. So here car goes back, its displacement with respect to starting point decreases uniformly, and it reaches back to the starting point where its displacement becomes 0 at 60 seconds. So now if we change this axis from distance to displacement, the gradient of the graph will give us velocity. So here constant velocity in the first part, no motion means gradient is 0, and it shows the car was stationary for 15 seconds and then car moved back with the constant velocity. And let us calculate what is the constant velocity of the car when it goes back to its starting point. Minus 2 meter per second. 0 minus 30. Final position 0, and the position when car moved back was 30 meters. So it covered 30 meter in the backward direction in 15 seconds. So speed is magnitude of speed is same, but minus sign here indicates the direction is reversed. And remember this slope decrease, this negative gradient does not show that the car is decelerating. You have to remember it. Sometimes students make mistake, and this portion of the car, when the car returned back, they write it deceleration. It is displacement time graph, and gradient gives velocity, not acceleration. Now let us recall few points. Gradient or slope. Gradient means division. Change in y-axis with respect to change in x-axis, whereas area is multiplication. We can find out two quantities from the graph, but here area gives nothing, whereas the gradient of this distance time graph or displacement time graph gives us either speed or velocity. Change in the quantity on y-axis divided by change in quantity on x-axis. So gradient gives the speed at any instant, because speed may not be constant throughout also. If car does not cover equal distance in equal interval of time, or any body does not cover equal distance in equal interval of time, the speed will not be constant. It will be different at different point. So we will apply the method in the next part of it. Area, what does it give? Nothing. Area of distance time graph or displacement time graph gives nothing, because area is multiplication. Change in the quantity along y-axis multiply by change in quantity along x-axis. So distance multiply time means the unit is meter multiply second, and no physical quantity has unit meter into second. So area of displacement time graph or distance time graph does not give any information. Now, let us assume that the car, after it covered 30 meters and stopped for 15 seconds, it accelerates forward. It speeds up instead of returning back. Then it slows down and stops. So here, the next part, after the portion of the graph which is parallel to time axis, the velocity is or speed is changing, because the graph does not have constant gradient. So we are choosing here 2 point. One is A and the other one is B. What is the speed at A? What do we have to do? And what is the time when the point A is marked? The time is 50 seconds. So what is the speed at 50 seconds? Is this the right way? That is, the corresponding distance covered is about 35 or 36. So we may assume this is 35 divided by 50. 0.7 meter per second. But this is not the right way. This formula is applied when the body moves with the constant speed. But here there are changes in the speed The first part of the journey had speed of 1 meter per second. Then there was no motion. Then the car accelerated. So it means we cannot say that the total distance covered in 50 seconds. Total distance is 35 here, but it is not the speed of the car at that point A when time is 50 seconds. So in order to find exact speed at 50 seconds, what is to be done? This is the wrong way, which is shown just now. And what will be the procedure? We have to draw tangent at that point. So since the speed is to be found at time of 50 seconds, so the two points are taken. One is at one end. It's not necessary that you take the extreme end. You can take any point on one side and the corresponding value of y-axis, that is distance. So it is about 46 and time is 60. This is y2 and this is x2. This is 40 and what is the distance covered at that time? It's around 23. So now we have to find out the gradient of this tangent. That will give us the velocity at point A or velocity at the time of 50 seconds. So change in distance divided by change in time. So what is change in distance? 46, the y2, y1, 23. What is x2? 60 and x1 is 40. So speed of the car at point A is 1.15 meter per second. This is instantaneous speed. And at the very next point, the speed will be, of course, different. Now let us see other point. This point has the increasing gradient and this point B has the decreasing gradient. So in order to find out the speed at point B, what is to be done? Let me erase all these things. Now the tangent is to be drawn at point B. And 2 points are to be chosen, y2, y1, x2 and x1. This is y2, it's about 65. And this is 75 is the value of x2. And 52 or 53 is value of y1. And 52nd is t1 or x1. So change in y-axis with respect to change in x-axis, change in distance with time, 65 minus 52, 75 minus 15, that is 0.52. So here the speed has decreased and that is shown by the decreasing gradient also. This tangent is less steeper than the tangent which was drawn at point A. So speed at B is 0.52 meter per second. So what we can say about this? The car was accelerating because the very first journey, 30 meter in 30 seconds, the speed was 1 meter per second. Now here the speed is 1.15 meter per second. It means speed has increased. So this part, the curve with increasing gradient shows acceleration. And the curve with decreasing gradient shows the deceleration. Though we cannot find out acceleration and deceleration from distance time graph, gradient tells us the speed, or if it is displacement time graph, the gradient tells us the velocity. But we can tell that whether the car is speeding up or body is speeding up or body is slowing down in these two positions. Between A and B, there is a region where the line is straight, means the car was traveling at constant speed. So here, let us suppose a point between A and B, which is on the straight line portion. Say the time is 55. Okay, at 55 seconds. So we don't again take directly the corresponding value of distance, that is 43. 43 over 55 will not be the right way. Instead of it, we will have to take the gradient of that straight line portion. Y2 x2, this is x1, and this is y1. So these values are to be noted down and they are to be substituted in this formula, which is shown here, delta S over delta T. And the speed in this region can also be found out. Now, this is the summary of the four graphs. You can assume it as a distance time graph or displacement time graph. One is parallel to time axis. The second one is straight line passing through a region. Third one is with increasing gradient. And the fourth one is with decreasing gradient. So what does first part show? Stationary. That means no motion because the distance is not changing with respect to time. What about the second one? This is uniform velocity if it is displacement time graph, or uniform speed if it is distance time graph. And third one shows acceleration because the gradient in the first part in the beginning is smaller, the graph is less steeper, and later on becomes steeper. Means the body is speeding up. So this is acceleration. And here the gradient is decreasing, means the body is decelerating. Now all four parts are combined in one graph. The first section is showing acceleration, then constant speed, then decreasing gradient means slowing down, and then the graph becomes parallel to time axis, that is x-axis where time is taken. So it means there is no motion, stationary. For distance time graph, the distance never decreases. As we saw in the first slide of this video, that after returning back, the graph was not having negative gradient. So that was drawn in the rising direction. When object is stationary, distance time graph will be horizontal. The gradient of distance time graph is instantaneous speed of the object. Few more points. For straight line with positive gradient, it means that object is traveling at uniform speed. There is no straight line with negative gradient as the distance never decreases. Okay, there is no negative gradient in distance time graph. It has to be then displacement time graph otherwise. For curves, it means that object is traveling at non-uniform speed, either with increasing gradient or decreasing gradient as the graph was shown. Now, displacement time graph. The details are similar as distance time graph, except that the distance is now displacement and time is now, and speed is now velocity. Time is to be taken along x-axis. This is common in both of them. And gradient gives us uniform instantaneous velocity. And one more thing, the straight line with negative gradient, it means that the object is traveling at uniform velocity in the opposite direction. This was also shown in the first slide when the car returned and reached back to the starting point when displacement became 0. Now, the displacement time graph may go to the negative side of the y-axis also. Displacement on the suppose right side is taken as positive, then left side will be taken as negative. If we can plot the positive on the positive y-axis and negative displacement on negative y-axis. So here the ball is stationary right now at the main position. Now it moves to right. So the displacement is shown here and then it returns. So when it passes O, the graph also is on time axis, means the displacement became 0 when the graph was at O. And then it became extreme displacement on the negative side, that is towards the left. So the graph is drawn on the negative y-axis. Then it returns, but it is still on the left side of the starting point. So this will be on the negative y-axis till it passes the mean position and goes towards right side of the mean position, the graph becomes now positive. Now the displacement is decreasing and this ball is reached back to the starting point. If it continues moving and goes towards the negative end, then the graph will again be plotted on the negative side, that is negative y-axis or negative displacement. Now this is a short question. And here the distance time graph is shown and we have to calculate the speed at t equals to 0. So the graph is starting from origin, that is 0 and 0. But it does not mean that the speed at t equals to 0 is 0. What is the right way to calculate speed at t equals to 0? Then we have to find out the gradient of the graph. So we have to, because the portion in the beginning is a straight line. So till the graph is a straight line, we can draw a line showing a value of y axis, and that is distance and time. And x1 and y1 are 0, 0. So this is a straight line portion. So what is speed? This is 18 because there are 10 small divisions are equal to 20, means 9 small divisions will be 18 and time is 0.8. So what is the speed? 22.8 meter per second. So remember, the speed is not 0. In the same way, but the speed is decreasing. That is shown by the decreasing gradient of the graph. And finally, what happens? The graph becomes parallel to time axis. When it means the object is stopped. And the object is car here. So that's all. And Allah Hafiz.